Looking at this next function, we see that there are 4 terms in the numerator, which lends itself to factoring by grouping. Let's take an x squared out of the first 2 terms, and this leaves us with x plus 1. We can factor a negative 4 out of the next 2 terms, and this leaves us also with x plus 1. So we can rewrite our function f of x as x plus 1 times x squared minus 4, which factors into x plus 2 times x minus 2. And we see that the denominator factors into x times x plus 3. Okay, let's now look at the numerator. The numerator tells us where the x-intercepts are going to be located, and we will see that they will be at -1 and plus and minus 2. Looking at the denominator, we see that we're going to have vertical asymptotes at x equals 0 and -3. We then look at what happens when we evaluate f at 0 to find the y-intercept. We notice the numerator is -4, but the denominator is 0, and that is undefined, and that tells us there is no y-intercept, which is consistent with having a vertical asymptote at x equals 0, which is the y-axis. We then look at the degree of the numerator and denominator and notice that the degree of the numerator is higher, and that tells us we will have a slant asymptote. That means we need to do some long division and divide by x squared plus 3x. When we do so, we notice that x squared goes into x to the third x times. We multiply to get x to the third plus 3x squared, and then we subtract or add the opposite and find out that we will have -2x squared minus 4x down below, and that x squared goes into that minus 2 times. Now we don't need to go any further than that because we're just interested in the x minus 2 here. Y equals x minus 2 will be our slant asymptote. So let's now go and plot all this information on the graph in an organized way. We know that the x-intercepts will be at -1, -2, and +2. We know the vertical asymptotes will be at 0, the y-axis, and at -3. And we know there will be a slant asymptote having a y-intercept of -2 and a slope of 1, and we notice that that will run into our x-intercept, but we don't let that bug us. Okay, we know what's going to happen in this center section because we have 2 points in there. It's going to look something like this. We don't know how low it's going to dip in the center there. That would be a matter of plotting a point such as -1.5. On the right hand side and left hand side, we know that we are not going to be approaching positive infinity because our denominator has vertical asymptotes that only show up once each. Had these been an x squared or an x plus 3 squared, we would approach the same infinity on both sides of the vertical asymptotes. But because these are odd multiplicities, they will approach different infinities. That tells us our graph is going to be approaching negative infinity over here on the bottom left, and so I can draw that curve in there. And I also know that my graph is going to come down over here to the right of the y-axis, come through, hit the x-intercept where it's supposed to, then go up and hug the asymptote at the top right.